All right, lesson practice 4.1.1a. Okay, now this wasn't sent home exactly as homework, but if you did want to see how to do some of these things, we'll show you by hand, and we'll also show you on the calculator how you can do that. So, Kirsten plays softball in the spring. Each game she records the number of times she reaches first base without being called out. Use the data in a table to solve problems 1 through 5. So, she would have 18 games and tells us the number of times at first. So first it wants us to create a dot plot showing the number of times Kirsten reached first base in each game. Okay, so first thing we do is we create a number line. Looks like the maximum was 5, minimum was 0, so 0, 1, 2, 3, 4, and 5. So we have 1, 2, 3, 4, 5, 0, so we draw 5 dots at 0, and 1, 2, 3 ones, so 3 dots, 1, 2, 3 dots at 2, at 3 we had 0 dots at 4, 1, 2, 3, 4, and at 5, 1, 2, 3. That's all we do with a dot plot. So what is the median number of times Kirsten reached first base? So we can use that dot plot to help us figure that out, or we can put them in order and do it that way. I kind of like to just think, okay, we've got 5 here at the lowest. There's 5 at the highest. 3 at the highest, 3 at the lowest, so we end up with 2, okay, at 2, which means normally we take those two numbers and we add them and divide by how many there were, by 2, and we get back to 2. Basically, if you have the same number, it's that. So the median number was 2. Okay, now it says find the minimum, maximum, first quartile, and third quartile of the data set. Okay, so because there was even, we cut that in half. Minimum, pretty easy to see, it was 0. Maximum was 5. Now to find the first quartile, we take that lower half of the data and we cut into it. And we basically find the median for it, which the median was 0, or the first quartile was 0. Third quartile, we do the same thing. Cut out all that data and we get it to be 4. Okay, and this is basically, all of these together is the 5-number summary, which allows us to then create a box plot. Okay, so for the box plot, again, we have a number line, and let me actually do that a little better over here. Okay, so at our minimum, we draw a bar. At our maximum, we draw a bar. Okay, at the first quartile, we draw a bar. It's the same thing, so it just stays there. Median, we draw it, and third quartile. Now, from the first quartile to the third quartile, with the median in the middle, we draw a box. Then we connect the whisker. Normally, we'd connect to the lowest, but because our lowest was the same as the first quartile, it stays there. Okay. Now it says Kirsten wants to analyze her performance using this data. She wants to understand the range of her data and the frequency of different results. Which graph, the dot plot or the box plot, will be most useful to Kristen? Explain. So here, why don't we do it on the calculator as well, and then we can use that to help us look. Okay? All right, so let's do this problem on the calculator now. Okay, so we start off here, and when you see the button turn red, that means that's the button I pushed. So we go to New Document, and we're doing statistics, so we choose Data and Statistics. Then we see that it says there's no lists in this problem, okay? Which tells us we need to make a list. The way we do that is by getting that, see that plus page in between the on and the doc button? We hit Control, and then we hit Doc, and that'll give us that extra page, and we can do lists and spreadsheets, okay? So once from our list and spreadsheet, first thing we need to do up there is we need to label it, okay? So we're talking about Kirsten playing softball and number of times at first, so let's just put first. That'll remind us which one we're talking about. Okay, in this box we generally don't put anything in there. Okay, and then we're just going to put the data we have. So 5, 1, 2, 0, 2 and 2, 4 and 4 and 0 and 0 and 1 and 1 and 0 and 5 again and 4 and 0 and 4. Now if I leave it like this, that last 4 won't be counted. So I got to make sure I hit enter or down. Okay. Now we go up here and we can see all our data. Now, one cool thing before we go back to the graphing is if we take a look at from here, we can actually do some stuff on this one to find some of those numbers that we had. So if I hit menu and statistics and then stat calculations and one variable statistics, now I have one list, so I'm going to hit OK on that list. What list do we want? Well, I choose my first. Result column, sure, we'll have it show up in column C, hit OK, and then we can find some data. Now, the only ones we really need to worry about is this one that's the X bar. That's our mean, so a mean of 2.2, okay? Then if we go down, we can ignore all the rest of those. But notice here it gives us that 5-number summary. Our minimum, our first quartile, median, third quartile, maximum. Okay, so there's a way that we can get some of those. The one it really doesn't tell us is the mode. Okay, but now if I wanted to delete that, we just go up here to the top and see how from here I pressed up one more time and then I can delete a whole column at a time. Okay. All right, so we jump back to tab 1.1. Notice now we've got some data. Okay, but what I need to do is tell it to organize this data. So I go down here where it says click variable, and I click, and then I click our first, and then it organizes it in our dot plot, okay, which is what we already had written on this problem, right? Okay. The other one we're going to do is a box plot, okay, box and whisker. So if I hit menu and go plot type, we can go to box plot right there, and we can see exactly what it is, okay? Now, Kirsten wants to figure out which of these graphs is going to help us understand her data better. Okay. Well, what we see here from this, and by the way, as I hover over the different points, it tells me what they are: first and third quartile, median, highest, and if we had a lowest, it would go there. So what I see from this box plot is I need to understand that each piece, this right here, is a quarter of the data. This first part of the box is a quarter. The second part is a quarter, and where the minimum would be a quarter. So basically this box here is half my data. So to understand just kind of an overall trend of how many times she's on first, I can see that about half the time she's from 0 to 2. Okay, and that can help me kind of understand big, larger trends, which if that's what she wants, that box plot is great for that. Now, if she wanted to be a little more specific, I think the dot plot is helpful because it can show you exactly how many times she was 0, exactly how many times 1 and 2. Again, the majority of my data is down here, or about half of it anyway. Okay, well, a little over half. And so that can help. That's another way, but that is more precise in showing exactly how many times she was in those areas, okay? And realizing that she was never there 3 times, whereas you can't really see that when we go to the box plot. So it kind of depends on exactly what she wants to get out of it. And if I click, you can see that it shows me kind of that there was data in all the pieces. So, which you think, I probably would go with the box plot, just because then it gives me the overall trend, because I don't exactly care how many exact times. I'm looking more at the trend, and I think the box plot does that pretty well. All right, on to the next one. Now we're going to take a look at the last 5 problems. So Dr. Singh is a veterinarian. He records the weights of each pet. The weights counts of 10 German Shepherds, all 4-year-old males, are in the following table. Round to the nearest pound. Use this information to solve 6 through 10. So now it wants us to create a histogram. Okay, so a histogram, it's all about making a frequency table. You've got intervals and their frequency. Okay, so it looks like our smallest is 78 and our highest is 89. So then it depends on how big you want your intervals to be. So let's go from like 78 to 80, we'll say, then 81 to 83, then 84 to 86, and you could have slightly different intervals. When we do it on the calculator, they'll kind of pick the intervals for us, and 87 to 89. Okay, so it all depends on how big you want your intervals to be, which will tell you. And maybe we should make these a little bit more intervals. Okay, so let's go 78 to 79, 80 to 81, 82 to 83, 84 to 85, 86 to 87, and 88 to 89. So from 78 to 79, we have 1. 80 to 81, we have 1, 2, 3, 4. 82 to 83, 1, 2, 3. 84 to 85, 1, and then 0, and 1. Okay, so then for our histogram, we're going to use those same intervals. So 78, 79, okay, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89. And then we go 1, 2, 3, 4. So for our first interval, go up to 1. Then our second interval, we go up to 4. Our third interval, we go up to 3. And generally they like them to be connected. The way we kind of did our intervals, it's not quite working that way, is it? Then 84 to 85. And then 88 to 89 was also 1. Okay, and there's our histogram. Now it wants us to find the median rate of the German Shepherds. Okay, so probably be a good idea to put them in order. Because that histogram doesn't really help us very well, does it, in seeing some of those pieces of information. So I'm just putting them in order. Okay, so then we 2 more. So between 80 and 82, so our median would be 81.5. Cut that in half. Okay, then it says find the minimum, 78, maximum, 89, first quartile, 81, third quartile, so we're kind of again 83. Going to use that to make a box plot. Okay, so there's our number line. Okay, our minimum was 78, so we draw a line at 78, maximum 89. Draw that. First quartile 81. Third quartile 83. And then median 81.5. So from first to third quartile, we draw our box. Then we connect our whiskers. Again, Dr. Singh wants to analyze the weights of the German Shepherds. He wants to understand the center and spread of his data. so that he has a better idea of an expected weight for a 4-year-old male German Shepherd. Which graph would be most useful to Dr. Singh? Explain. So again, let's see how we do this on the calculator and use that to help us. Here we are now on this last problem, okay? So Dr. Singh and the weight of the German Shepherds, the 4-year-olds, okay? So I want to show you guys something. Instead of going the normal way, if I go current, I can see that the data from my first problem is still up here, isn't it? Okay. So I could go up into that column and delete it, or I could keep both sets of data. So let's label this one weight. And if you have more than one set of the same type of data, it can be super helpful to be able to compare them. But I pick my weight, and then I choose, I enter in my data. Don't choose the data because they were given it to me. So we just, again, enter in the data from that table on problem 6 through 10. Okay, and I just have 10 points of data here. So again, I could look up those statistics if I really wanted to, but we don't need to do that. And we can see that information as well that we already found out by hand. Okay, but we go over here, and now what I'm going to do is I'm just going to choose a different variable. So I click here, and then I just go over and I choose the weight. And then now notice the scale changes and it organizes my data. Okay, but we didn't want a dot plot, we wanted a histogram, right? And a box plot. So I go menu, plot type, and I choose a histogram. Okay, now the way they split up their numbers is slightly different than us. Okay, and you can adjust that a little bit to see it. I think you can even adjust it to be the way we wanted it. I think if we go menu, plot properties, histogram properties, bin settings, equal bin width. I think if we did a bin width of 2 with the alignment at 78, that should look more like ours, okay? The one that we did. Now, we probably need to bring that down. There we go. Okay, that should look more like ours. And so we can kind of see that now Dr. Singh wanted to analyze the weight and see the center and spread of his data. Okay, so looking at this, we can see kind of that spread out, and we can kind of see how in between 80 and 84, that's where the majority of our dogs are at, their weight. Okay, but what about if we look at that box plot? Okay, now notice here we got this guy clear off to the right. Okay, that's an outlier. That's one useful thing about the box plots. It shows us an outlier. An outlier is basically something that's an anomaly. It shouldn't be there. It's so far above or below that it doesn't make sense with the other data. Okay, and again, we can see our numbers here, and this box here is half of our data, right? We've got our median right here, so we can see it's 81, our first quartile, our third quartile, our highest, even our lowest. Okay, but half of our data is in that box, which tells us that, between the 81 to 83, 84 is where the majority of our German Shepherds are going to be. Okay, so it's not super spread out except for this crazy guy out here. Okay, and so looking at that, okay, that box plot again can kind of give us an idea of how spread out it is, but the histogram does a pretty good job of that as well. And with the histogram, we can definitely see, and it looks like it went back to its old way, we can see where the majority are. Okay, and using either one, we could probably tell Dr. Singh that, if he sees a 4-year-old German Shepherd, it's going to be around that 80 to 84 pounds, okay, in that range. So personally, I probably like this box plot, just because I can see where the majority of my data is. I can also quickly see the median, and it shows me this outlier that is an anomaly and that's not normal. Okay, so there we go, guys. Hopefully that helped you understand how to do it with the calculator and by hand, and to kind of compare the two.